Out of them, but just to remind you guys, the homework. Let's see. Turn this on. What's happening? All right, let's see. So the homework, because you can download the PDF of the book, right? You can get a print copy if you want to, $33 or whatever it is. You can view it online, but whatever way you do it. So if you look at the textbook, so you can download the PDF, you can order a print copy, so forth. View it online, I think, is probably going to be the most popular choice. If you're looking for the homework, it's always going to be practice and homework. So there's the homework for chapter 3, right? There's the first part of the homework for chapter 3. And there's the rest of the homework for chapter 3. And I kind of talked about what I think they wanted to do with those two sections. And I thought maybe I could do the practice problems in class and the homework problems for homework. But some of the problems are not good. So I just had to pick what I could between the two, just to make a complete homework assignment. Okay, I like it. All right. So that's true for every chapter. Okay. While I have this up here, let me mute my email. Yes, any questions from homework? Yes?
I have a question from the homework.
Yeah.
How do we find if it's financially exclusive?
Oh, okay. So two things. There's a couple homework problems. In fact, let me pull these up here. I think it's in the 40s. Yeah. This little section right here, right? And this might not be the one you're talking about, but I'm going to answer your question. People just skip over this first sentence, and then they try to start doing the work over there. But there's no way in hell you're going to do the work, because these first sentences here are huge. They tell you huge amounts of things. So two things are mutually exclusive. Who remembers what that means?
0.
They both can't happen.
They both can't happen at the same time. So if A and B are mutually exclusive, what's the probability that I have something happen that's both A and B?
0.
0. So the minute they tell you E and F are mutually exclusive, you know that the probability of E and F is 0, right? So you write that down. So let me do E and F. So E and F are mutually exclusive, so I'm going to write down probability of E and F equals 0. Okay, we'll talk about independent here in a minute. What's the formula? So again, I don't blame you. You're in a math class, so you're like, words. Okay, numbers now. Okay, great. But this is actually telling you a mathematical idea. It's telling you this fact. What's the formula for, how do you even say this, by the way? PEF. No.
E given F.
E given F, kick ass. And what is the formula for the probability of E given F?
E and F.
Yeah, probability of E and F
Divided by F.
divided by probability of F. And of course, E and F, the probability is 0, right? You guys semi with me? So there's a problem later that you have to calculate the and if it's anything other than 0, they're not mutually exclusive. If there's any overlap, they don't mutually exclude each other. I love it. Now real quick, who remembers what the hell independent means? Hopefully some of you do, because we just had a test about it, or a quiz. If two things are independent, so J and K are independent, Does anyone know what that immediately means?
That they have no effect on each other?
No effect on each other. I love it. So if one happens, does the other one give a shit?
No.
No. What's the only probability that assumes something happened?
J.
It's a weird question, I know. The given. Given that this happened. So the minute they tell me two things are independent, I can write down the probability of one given the other one is the same as the probability of the guy by itself. I really want this to make nothing but sense. K happened. Given that K happened, J shouldn't give a shit. Right?
Mhm.
Therefore, it stays the same. It doesn't change. That's what it means to be independent. So you see how 41, there's no work to do. It's just applying the idea directly, right? Okay, maybe. So these are, so again, the big thing about statistics, there's not a lot of algebra in it, but there's a hell of a lot more concept in it. So there's going to be problems like that where there's actually no work to do. You just have to know what the idea is. Okay. Maybe.
For chapter 4, actually today, like, what chapters from chapter 4 should we do for the homework?
Well, you got 4, 1, 4, 2, 4, 3.
Yeah.
And hopefully today I'm going to be able to get through into 4, 3 at least. We'll see.
Okay.
Yep, that's my hope. So right now, you should be obviously done with chapter 3 homework because we just had the quiz on it, or at least have done enough of it so you were ready for the quiz. And then I would say over the weekend you should be getting into chapter 4 homework. Right? We've already done section 4.1 and 4.2. Yeah. Well, we're not quite done with 4.2 yet. Okay. Okay, I love that question. It's a conceptual question. Those are the freakiest ones. Anything else from homework, about the quiz, about anything? Okay, all right. And remind me, if you get homework back from me and it says correct or redo, when is that due?
Before they do it? Before they do it?
Final.
Day of the final. Homework corrections. You got all the time you want until the day of the final, right? Because the final is going to be cumulative. So I'm like, any practice you get. So if you do chapter 1 corrections the day before the final, you're studying. It's crazy, right? When are quiz and test corrections due?
Next.
The day of the next test. Good, because that's the way I kind of keep things a little fresh immediately. And the homework you just do whenever you can, the corrections. I want you to focus on the new homework. All right. There's a reason behind every choice I've made. Okay. So, if there's no other questions, we're going to get back into where we left off last time. And I am desperately, I need you to start to realize that a lot of the formulas we create them together. So the symbols can be a little daunting, like the summation symbol and all that, and the little Greek letters. But you just have to remember, they're built off of really straightforward ideas. So what we did last time was we remembered, that's the formula from before for average. So I took a list of numbers. I'm not going to redo it, right? Took a list of numbers. We sort of calculated it this way, and then we figured out a different way to do it because there were a lot of repeats, right? So if I ask you to add 4 10s and 3 7s, you're not going to go 10 plus 10 plus, no, you're going to go 4 times 10 is 40, plus 3 7s is 21, right? You're going to do that shit, right? You're not going to add each one individually. So that's basically what this new way of doing it is. If they don't give me the list, but they tell me how many times a number shows up, there should be a shortcut. So really, this is just a shortcut way to do things. So if they give me data like this, let's do one real quick. What you got, Jeff? I want to do this a certain way. Let's do point. So what's that leave me? 13, 22, 78, is that right? Maybe. What am I trying to make sure happens?
Adds up to 1.
Has to add up to be 1.
So for this one, this equals 1, but for the old one, it was 0?
No, be careful. You're thinking about standard deviation.
Yeah.
We haven't started doing that at all yet.
Okay.
Yeah, for the old one, it was just add the numbers, divide by n.
Okay. Fine.
Again, this isn't really new. It's just a different way to do the same math. I really wish you guys could see that. Here's this formula. This is a formula you came in knowing. You guys knew how to freaking calculate an average before the first day of this damn class, yes? Yeah, it's easy shit. All right. So the idea here, the formula for this was, if I have it given to me like this, the formula is multiply x times p of x and then add them up. Now, because I am weird, I'm trying to tell you these are the same damn formula. And when you first look at it, it's completely fine for you to go, I think you need to seek help, Jeff. Right? Because something's wrong with your eyes or your brain or something. But remind me, how do I construct any probability? What goes in the bottom of the probability?
The total.
Total number. And of course, what variable do we give that? N. So isn't the over n built into the freaking probabilities? So these are the same formula. It's just, if they give it to me like this, I want you to really understand this. What is the denominators of these guys? 100. Isn't that 5/100ths? You guys with me? So if you wanted to do it this way, you'd have to write 5 10s, 9 20s, 78 30s, and 8 40s. And then add them all up and divide by how many there are. Do you want to do that? No. So again, I really want you to see this. This is a shortcut way to get the same average if I'm given the data like this. Now, what does this data mean? Which data point? Well, what's the data points? Can somebody just tell me what the data points are?
10, 10, 10.
Well, 10, 20, 30, 40. And there's a certain number of each, yes? So the data points are 10, 20, 30, 40. So whatever this question was, those are the only responses I got. Now, obviously, which response did I get the most?
30?
30. How often did that happen? 78% of the time. Right? So if I said, what's probably somebody told me 30? It'd be 78% chance. So you can look at this P as probability or as percentage because they really are the same thing. Okay, I like it. So then to actually do this problem. Now real quick, can somebody guess what should the average be close to? And again, what's the heaviest weighted number? What's the number that occurred the most? 30. We had breaking news about Iron Man. I love it. We interrupt this regularly scheduled lecture. 30 occurs the most.
It should be just below 30.
I like it. So it should be close to 30. And in this case, just below because there's a couple things below. I really want that to make nothing but sense. Whatever the most common number is should probably be kind of close to what the average is. It's going to affect it the most. And I called it like gravity last time. So even before we do this, my guess for the mean would be like 28 or something. Should be close to 30. Now let me show you this. Let me go ahead and show you this. You all have calculators. You should all have calculators. So let's do this in the calculator, make this quicker. I don't think it was on this computer, was it? No, it's here. Sweet. So in your calculator, can you pull up your lists of data? Remember how to get to your lists? So we go to Stat, Edit. So let me clear these out. Clear this out. Clear this out. So go ahead and put, just like it is, put the X's in L1. we're basically gonna recreate the table we did yesterday, but we're gonna have the calculator do it for us. Now put the P of X's in L2. Let me know if you need any help. Yeah. Oh, it's that. And then to clear those, you would go up to the list, hit the up arrow, and then hit clear. Enter. So you go over up, hit clear, enter, or load. Yeah. All right, guys. It's that. Edit. And then go, if you go up, hit clear. Enter. Keep doing that. Okay. And then you can put that stuff in. Okay. All right. All right, so now, I'll give just a couple seconds here for people to catch up. So all I've done is I put, this is L1, this is L2. So what do I want L3 to be?
L1 times L2.
Yeah, X is L1 times P of X, L2. So I want L3 to be L1 times L2. I really want you guys to see how to tell what to do, because this is gonna make this shit a lot quicker. Make the calculator do all the multiplying, and adding, right?
So just do L1 times L2.
Yeah, so you go up to L3, see where I am? Go up to L3 and it's gonna say, what do you want L3 to be? Well, I would like L3 to be L1 times L2. And that's X is in L1 times P of X, that's in L2.
Do you know how you, I forgot, you just went a little too quick.
Yeah, let me do it again. All right, everybody's got the L1, L2 stuff in there, right? Right, everybody's got this stuff in?
Yes.
So now, if you want to tell the calculator how to populate a list, how to create a list itself, you go up to the list, and now see how it's saying L3 equals what?
Yeah.
So I'm gonna tell it L3 equals L1, because that's where the X's are,
Yes.
times L2, because that's where the P of X is.
Oh, okay. Thank you.
You're welcome. Now, obviously, this is a small list of data. It doesn't really save a ton of time to do it this way, but I'm not going to give you as small of a list of data, so this will be a lot quicker if I got a longer list of data. So see, this is 0.5, 1.8, 23.4, 3.2, and now how do I get the average?
You add them all up?
Add them all up. So the mean is the sum of XP of X. Now real quick, again, this is not a very long list of data, but just to show you, how do you make the calculator do this for you? First thing you want to do is you want to get the hell out of your list, right? Because if you try to do something right now, the calculator's going to try to put it in the list. I really want to make sense. So the first thing I want to do is to get out of here. I want to hit second mode to quit. That always gets you back to this screen.
You were close.
Hmm?
You were close for the mean.
Oh, really?
Yeah.
Okay. It's almost like I've been doing it. No, I just, I can get close. Normally. Now watch this. I want to do something to this list, correct? I want to do something to this list. In fact, I want to do math to this list if I want to really sound weird. I want to add this freaking list up, correct? That's what I want. So let me go to list, because that's what I want to work on. I want to add that list up. So let's go to list. I think I've done this before, but it's been a while. So if it's second stat, I can then go over to math, because I want to do math to it. I want to sum it up. Number 5. Let me do that again. Second stat. That gets me the list. I want to do math on a list. I want to sum up a list. Which list do I want to sum up? L3. So the L's are always right above the same number. So L3 is above 3. That's great. So if I enter, it tells me the average. Yeah, I was pretty far off. It's all right. I got close. Let me stop for just a minute. Now again, real quick, I'm just showing you how to do it in the calculator in case you need to, in case you get this long ass list. But if it's a short list, it's actually just quicker just to do them step by step. Okay, so I really want that to go along with, we knew already that the average should be close to 30 because that's the heaviest weighted thing. So I knew it was going to be close to 30. And like Edmundo said, it should have been a little less than 30 because there were a couple of data values that were less that would pull it down a little bit, right? Okay, do you guys sort of get a feel for that? So you should kind of know that anytime you do any math, it's great if you have a way to tell if your answer makes sense. So if the mean I got here was, can somebody tell me why, if I got a mean of 7, why that makes 0 sense?
Because it's lower than your lowest.
It's lower than any freaking data point, and the mean should be in the middle somewhere, right? Okay, but I've seen that happen. I've seen people tell me the mean here is 300, Jeff, and I'm like, no, it doesn't make any sense. You know something went wrong. So real quick, on a test or a quiz, if you get an answer and you're like, that's wrong, but I don't know why, just write that. I know this shouldn't be this. You'll get a point for that. You'll get something, because if you just leave it, I'm like, oh shit, they think that makes sense. That's not good. So say, hey, I don't see why, but this shouldn't be 300. It should be so, Does that make sense? That's perfectly fine to do. Please, dear God, do that. So I don't think you think it's possible that it's some crazy number, right? Okay. Okay, so what we need to do now, and let me just keep that there. We got the formula for the average. What's the other? I really want this to make sense. No matter how somebody gives me data, and I said this last time, what 2 numbers do I want to be able to calculate for that data? The mean? Standard deviation. So I want to know where the middle of it seems to be and how spread out the data seems to be. Now, real quick, can you guys tell me this data right here? Can you guys see if that's very spread out? Where's most of the data? Yeah, really close to the mean. Most of the data, 78% of the data is right next to this. So the standard deviation for this should be relatively small. I really want that to make sense. Okay, so again, we already have an idea. If I get a standard deviation of 50, I am wrong. Because 78% of it is 30, which is right next to the average. It shouldn't be a very big standard deviation. Okay, maybe. So, last time I got to this point, again, I really want this to make sense. To figure out the mean, instead of adding these divided by n, I multiply those by p of x. To get the standard deviation, instead of adding these up, let me do it this way. Here's the old standard deviation. You put old in quotes. Let's say variance. Okay, just to make it easy so I don't have to draw a big ass square root. Does that formula look at all familiar? A little bit, okay. So that's the old one. And again, why does this freaking make sense? Because I want the standard deviation to tell me, on average, how far away from the mean do the data points get? If I want a number that tells me the spread of data, doesn't what I just said make freaking sense? On average, how far away from the middle do they get? That'll be a measure of spread. And sure enough, this is how far each data point is from the mean, squared, because some of them were negative, remember? So if I add these up, divide by how many there are, that should be an idea of how far away from the middle they get. Now, let's see if this makes sense. So now, when I'm given x p of x, just like with the mean, instead of doing this divided by n, I do this. Instead of doing this divided by n, I take this and I multiply by p of x. Same exact freaking way. Because again, what's on the bottom of p of x? N.
So it's just L3 times L2 pretty much?
No. No, we don't even know what the hell this is, right?
Oh, okay.
So. Let me stop right there. So this guy looks a hell of a lot like this guy, especially when you remember this has an over n in it. Okay, I'll stop. I just really want you guys to understand what I just said. That would be beautiful, because then you can see these really are the same formula. It's just I use this when I'm given these. Bam. I don't use it when I'm not given those. Bam. Okay. Now, this formula sucks. Can anyone understand how many more, do you see how many more columns I would need? I would need x minus mu, I'd square it, and then I need another column for multiply by p of x. So, we're going to do a little algebra, or more specifically, UR. You're going to do some algebra. What I want you to do, let me just take this part of it down here. If you're in algebra class, let me just do this piece. And I say simplify this.
Yeah.
What would you do?
X squared minus.
And don't tell me the answer, just tell me what you would do.
You would do quadratics. You would put it like into a square.
Yeah, the FOIL thing, right? Because what is something squared? It's it times itself. All right, go ahead and do that real quick. Oh, wait. Go ahead and multiply that out.
Do you want to say? Like
Don't say it. No. Everybody just do it. Don't say anything yet. A little algebra review. Foiling's not terrible. And real quick, I wish they would have never come up with that. When I say this, do you guys know what I'm talking about? FOIL?
Yeah.
First, outer, inner, last. So if I multiply x plus 2 times x minus 7, first, outer, inner, last, right? So part of me kind of hates that I just told you that, because I personally wish we had never made that shit up. Because when we do that, when we create these mnemonic devices, FOIL, we're telling students, hey, this shit's hard unless you know the FOIL. No, this is stupid. Real quick. How would you do this?
3 times that.
Yeah, distribution, right? Distribution is one of the best things. You see that shit, you're like, yes. Or you should be, right? Because this is just 3x minus 21. Yay. This is there one thing in front of x minus 7? No, there's an x. It gets a turn. X times x. X times negative. It's just distribution. And then the freaking 2 gets a turn. So now distribute the 2. Distribute the 2. So I don't have to know FOIL. It's just repeated distribution. Yeah.
I was gonna say just the reason I don't like foils because it only works if you have 2. Like
That's the other thing. So my big joke when I teach an algebra class this is the minute I've got this, then what would that be? Because now you need a middle, right? Screw that shit. This guy gets a turn, bam, bam. This guy gets a turn, bam, bam. This guy gets a turn, bam, bam. It's just repeated distribution, exactly. And I wish to God we would teach that, but oh well, too bad. So coming back to this, who's got what this is?
x squared minus 2x.
Yeah, you get 2 of these, right? Minus mu x, so minus 2 of these.
Plus u.
Good, plus mu
Squared.
squared. Okay. I know you guys look so excited. You're like, this guy told us there was going to be no, I didn't say no algebra. I said very little. All right, so watch this. Let me do the rest of this. Let's see. Where am I going to do this? I can take you away. So, bringing this up here. I've got the sum of x squared minus 2 mu x plus mu squared times p of x. Is that cool? Right, just put that here, right? So there's the times p of x. You with me? Man, I can feel you guys turning off. We're almost there. We're not going to do this whole thing. Don't worry, because part of this would be summation notation algebra. I'm not going to do that much. But would everybody agree with me that the very first thing you get is x squared p of x?
Yeah.
And then you get minus other shit? Yes?
Yeah.
Okay. I like it. So, I might make this a bonus question, maybe for you to finish this out. But let me tell you what the answer becomes. So, this formula is true. This is a true formula. It just sort of sucks with the way we've set things up. What's much better, what this actually ends up becoming, is this. Somehow all the extra shit just becomes this. That's crazy. So this is the formula we're going to use for the variance. Let me see if you guys can see. You guys all agree with me that's definitely in there, yes?
Yes.
Now again, there's a little bit of weirdness about what's happening with the rest of it. But if you do the work, you will eventually get here. Okay.
So that's a variant?
That's the variance. These two equations are the same.
Okay.
This has just been simplified. Now, some of you guys might look at me and say, that's not simple, Jeff. But here's the beautiful thing. Do you guys notice how many more columns do I need to do that formula? What do I need to add up? I need to add these up, yes?
Yeah.
Don't I already know what the mean is?
Yeah.
Yeah. So I just need an x squared p of x column. Because isn't that what I want to add up? Remember what I told you when you see one of these formulas, you cover this up and you go, oh, I need a bunch of these. So then I can add them up. In the calculator, what would that be? So if I go to L4, let me go back to stat, edit.
That'd be 1 times L3.
Yes, beautiful. That's the way I do it. Do you see how this is already x p of x?
Yes.
And I want x squared p of x. Isn't x times x squared?
Yes.
P of x, right? And don't worry, I've got a handout that's got kind of these labeled up there. L4, I want it to be L1 times L3. What is x times p of x?
Squared P of X.
X squared p of x. I love it.
So how would we put in L4?
So if you go to L4, right? So there I am, I got L4 highlighted. I'm gonna say second 1 for L1 times second 3 for L3. Now again, I know, I'm not sure how to communicate this to you, but I understand there's a disconnect between idea and formula and actually freaking doing it nuts and bolts. I'm really hoping you can see how that's an over n. It's the same formula that we used before for standard deviation. It's exactly the same formula, variance. This came from doing some algebra to this. And the reason this formula is better is because I only need one more column. So we get 5, 36, 702, 128. So then you can do the same thing with the list, or you can just add those up. 143. 871.
871.
So the variance is going to be the sum of x squared p of x minus the mean squared, like we said here. What is this piece? Do we know what that piece is?
871.
Yeah, the sum of these is 871. The mean was 28.9. And I'm going to square it. The biggest thing people must forget is to square that mean. Cool. And then you just throw the old calculator. That, of course, is the variance. The last step I have to do to get the standard deviation is to square root it. So see what we get here. 871 minus 28.9 squared. So that's the variance. So then if I do the square root of that, that's the standard deviation. So standard deviation is definitely smaller than the data points because most of the data points are right next to 30. Right? So the standard deviation is not even 6. Okay. Now, to do a problem, you must do all of that. You must do everything we just did. I'm going to show you the shortcut to make the calculator tell you the answer directly so you can check your work. What I'm about to do is never good enough for the work. But it's good to know, freaking calculator is expensive. Can't it just tell me the answer? Yes, it can. Can somebody tell me, what's wrong if I said that this represents my full data set?
No, it doesn't show.
10, 20, 30, 40. Does that tell me? No, because then I think there's 110, 120. So isn't my data contained in the first two lists? You guys with me? In fact, if you go back to when we were doing histograms and stuff like that, isn't this sort of like the relative frequency here? 78% of the time it was a 30, 9% of the time it was a 20, 9 out of 100, 78 out of 100. Okay, so watch this. If I do one var stats the way we used to, right? Good old one var stats. That's when we just had a list of data. We're going to finally use this guy, the frequency list. Now, does anyone, real quick, let me go back. If you go to stat, calc, one var stats, does anyone not have this show up? Does everyone's look like this? Everybody's looks like this? Okay, all right. On calculator day, you speak up or forever hold your peace. Frequency list, L2. Does anything up there look familiar?
Yeah.
The mean, 28.9. Standard deviation, 519, blah, 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 right? Okay, and again, don't get too excited because this is how you check your work. Right? And I've had people, even after I said that multiple times, I've had somebody turn and test it and said, I pushed this button and I got this number, that's my work. I'm like, no. Okay. So it's good to be able to check your work. I love it. Let's see. Let's do this. Yeah, let me do something very quickly. I'm not sure. Let's see. This will be interesting. Do it, Jeff. What is that? Is that 50? Okay. Nifty. Well, that's not what I want. Let's make this 4 and that 1. Okay. Maybe that'll work the way I want it to. Let me see if you guys can answer this question before you do any work. This standard deviation was 5.982. We said beforehand, before we did any of the work, we said the standard deviation should be relatively small because most of the data was really close to the mean. Does anyone have an idea, should this guy's standard deviation be bigger or smaller than 5.982?
About the same.
Why?
Because there's the most for 30.
Yeah, but there's only 35% of
So
it.
smaller.
And I don't know what the mean is yet,
Oh.
also, but the mean should be around here somewhere, right?
Yeah.
That's what I'm trying to create. Do you guys see how this is this more spread out than that?
It's more
What
clear.
percent was 10 before?
10 was 5%.
Just 5%. What is it now?
10%.
10%. What percent was 40 before?
8%.
Now it's
15.
15%. So isn't it more spread out?
Yeah.
Don't more of the data points get further away from the middle? Okay. All right, so let's do this in the calculator real quick, just to get the answer quickly. So if I go back here, I can just update my probabilities. 0.1, 0.4, 0.35, 0.15. And again, this is just for, we're not going to do all the work. I just want to see. I'm going to make the calculator do it for us. Stat, calc, 1 bar stats, L1, L2. So it means a little bit less. I knew it would be because I made this a little too heavy, but too bad. But the standard deviation is now 8.645, bigger than it used to be. Because again, this is more spread out. All right, so let me give you this. There's a little handout about this stuff.
Maybe.
All right, so I have, as I often do, I've got one side of this completely worked out. And then the other side, of course, is for you to do. Okay, so just want to put a couple of things out on this worked out side. So it's basically the same idea, right? Gave you some data, gave us some probabilities, blah, 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 blah. So here's all the sums and so forth. So when I get to the formulas, I can just plug them in down here. I've asked a couple questions about probability stuff. So why is this a valid probability distribution? There's two things that has to happen. One of them we already talked about. The probabilities all have to add up to be 1. What's the lowest the probability can be? Can a probability be negative?
No.
Hell no. What's the highest the probability can be? Probability?
1.
1. So two things have to be true for this to be valid. Every probability between 0 and 1, and they all add up to be 1. So when I ask you on a test or a quiz, I say verify this is valid, you have to check those two things. Now, let me ask you this. I'm going to warn you right now. Back in the day when we made histograms, did our frequencies, our relative frequency, did it have to add up to be 100%?
It can be like 0.2 off or something.
Yeah, it could be off a little bit, yes? It could be like 0.993 or 1.00, whatever. So listen to me very closely. All right, I'm telling you something right now about what I'm going to do to you on the test. I'm going to give you probabilities that do not add up to be 1. They add up to be 1.002 or 0.997 or something. You guys with me? So if you just say yeah, it's valid because the sum is 1, I'm gonna be like, you didn't even look. You should say, yeah, it's valid because the sum is 1.002, which is close enough to 1. Does that make sense? If I add up those freaking probabilities and I get 1.47, screw that. Somebody messed up. That's way too far away. That's not explained by rounding errors. That's just crazy. That's 47% off. Whoa. Okay. I ask a couple probability questions, and then I give us this crazy thing. And I'm pretty sure I told you this before. So do you guys remember doing this problem where you put the mean in the middle and you go, in this case, you're going to go up 2 steps and down 2 steps. Well, actually, this was one. Oh, yeah. What are the probabilities? Okay. So here I just went up 1, down 1. Okay. That's right. Later I'm going to do the up 2, down 2. So we've done this kind of problem before where we go up 1 step, down step, and then see what the total probability, the total percentage is in between those two. Okay, so what I want you to do, I want you to try this side out. So give this a try. I've got these labeled so you can put them into your calculators pretty well. You can work with other people near you if you want to. Are those looking like the numbers you guys got?
Yeah. I was checking, and that being slightly off. Does that mean is that because it's got the n-1 underneath, or is that like actually off?
No. This is the full. Yeah, something went wrong.
That's what I'm saying. But like these.
How much did
are
you? Yeah, you didn't round this at all.
Yeah.
Let me catch up to you.
Okay.
Because the probabilities add up to be 1. Is that correct?
Yes.
Mm-hmm.
I think I made this one 5, 1, 6, 7, 1. Yeah. Sum of the probabilities is 1. What's up, sir? Oh. Yeah. Okay, you ready?
Yeah.
Watch how much. You're trying to put an entire list into one place. So hit the up arrow.
This one.
Now you're telling it what to make the whole list. Yeah. Okay.
That's wonderful. Thank you.
No worries. That's easy, believe me, I've done that before. Okay. So then I can do the quit, I can go to list, math, sum, and the beautiful thing about doing this is once you got it up on the screen, I want to sum up L3, and then if I hit second enter, I can then just go ahead and put L4, so I don't have to go through all those freaking menus. So on both of those, so 45.89, and 2410.89. Okay, let me stop for a minute.
So far, so good.
Yeah, and again, real quick, do you see how this is the heaviest weighted thing? But these two are each pretty close to as heavy as this, so these together pull the mean down a bit, so this makes sense. And it should be pretty spread out because there's 29% up here at 65, and then there's 47% in 25 and 40. So the standard deviation should be kind of bigger. And again, you don't have to know all of this ahead of time, but it's kind of nice to know what to expect. What's the probability that somebody's picked it who believes there'll be at least 25?
It's 25. Yep. I did 1 minus
Yeah.
probability of
So you could do, what's at least 25? 25, 40, 50. So you can add all these up, or you can stop and realize these all add up to 1. So if I subtract 0.04, I get what these add up to be. 1 minus 1 piece is the rest of it. That's just like the probabilities 1 is 1 minus probability none. These all add up to 1. So what do these add up to be? 1 minus 0.04. Or if you don't understand that, you just add these. It's just quicker to do 1 minus 0.04. So real quick. 0.04 plus 0.24 plus 0.23 plus 0.18 plus 0.29 plus 0.02. What does that equal? 1. Yes?
Yeah.
So what's 1 minus 0.04? Is it equal to these?
0.96.
Yeah, 0.96. So either way you do it, you should get 0.96. This one I know, I don't have to do any work for. It's just 45.89. The standard deviation and the variance I have to do some work for. Let's see what happens. So this is 2410.89. And the mean is 45.89, and I want to square that.
304.
Yeah. Now, here's the trick. You don't want to round this at all. Let me stop for a minute. Are you guys with me at the moment? Okay. So now if I do the square root of that, you get 17.439. Yeah. And then if we check it like we did earlier, stat, calc, 1var stats, make it L1 and L2, let's check it. Yeah, that is off a little bit. I wonder why.
I see why.
Why?
Because
I have that.
we both did the same error of when you put in 2410, you didn't add the decimal. You put just minus, you put 2410 instead of 2410.89.
Oh, I totally did. Thank you.
Yeah.
Alright, so now if you take the square root of that, there we go, 17.464, that's better. Now, what's funny about that, I can try to pretend like I did it on purpose, but obviously I didn't. That's why when you check your answer on the calculator, you can kind of catch a mistake you made on the way, if it's not the same number. Okay. So what does all this mean? So the middle of the data is 45.89, and on average, the data points get this far away from the average. So that's pretty spread out. That's a pretty decent sized standard deviation. So if I put the mean in the middle, and they go up 1 step, and they go down 1 step. Where's that? So if I do 45.89 minus 17.6, I'm sorry, 464, that's 28.426. And if I do that same thing but plus, that's 63.354. Now, we've done this before. There's a slight difference here though. Can anybody tell me which data points are in between 28 years old and 63 years old?
40 and 50.
40 and 50, yes? If I catch all the people that said 40 years old, what percentage have I caught so far?
23%.
23. And then I also catch all the 50-year-old. So what's the total percentage then?
41%.
41%. So the nice thing with this one is I don't have to divide by the total because they're already percentages. I just have to add up all the percentages of what I caught. Alright. And the last one I will do next time, I gotta get back to the Math Study Center, but, one of my tutors is sick, poor guy. So, next time we'll do section 4.3, get into chapter 5. I'll have the quizzes graded next time. And as always, you'll be able to make corrections if you need to. Don't forget your stuff. If you borrowed a calculator, please don't forget your stuff. See you good.
I'm gonna run through something really quick.
Yeah.
If you don't mind. Okay, so, when you're doing the fucking average for that, right, you just put the P of X at the end instead of dividing it by n.
Yes.
Does that just mean that P of X?
No, because
when you're
because, and again, it's exactly the math I did where I said, here's a list of 10 numbers, here's the old way to do it. So it's the over, remember when I had 10 numbers, every probability was over 10. But if it was 2 over 10, that's because there are 2 of those things.
Okay.
Okay.
Because it was weird, because I was looking at it, and it was like, just simplifying the probability equation, it was like A times B over C, you get rid of A times B times C. It's like these two different ways of finding it, so then that just made me think that C was that.
Oh, I see.
You know what I mean?
It's it has an over n. I kept trying to be really careful. It has an over n in it.
Yeah.
I never said it was 1 over n, but on the top would be the number of each data point. Yeah, yeah.
That's why I was a little weird about it.
Thank you. Oh, cool, thank you. Yeah.
What we just did.
Yeah.
I was wondering how'd you get point back.
Oh, yeah, alright, alright. So, where'd this paper go? No, I took it somewhere. Oh, I really want this to make sense. Don't all of these add up to be 1? So wouldn't 1 minus part of it be the rest of it? So like, so it's exactly this. So if all of them add up to be 1, what do these add up to be when they add up to be 1 minus 0.04? So 1 minus, so if 2 numbers add up to be 10, 10 minus 1 of them is the other one. So if all these numbers add up to be 1, 1 minus 1 of them is the sum of the rest of them. It's just a shortcut.
Oh, okay.
Yeah, yeah, I like it. Good.
Thank you.
You're welcome.